Hi guys, good afternoon. So in the last session, we were going with the EIGRP and we were talking about EIGRP neighbors. So this is something that I gave you as a task. So first task was about the neighbor table that you have to check what are the contents of the neighbor table. And second thing was for you to check whether EIGRP neighborship can be formed on the separate secondary IP address or subnet. Okay. So did you guys check it? What is the answer to the second one? Answer is no. You cannot form an EIGRP neighborship on the secondary subnet. Okay. And if we talk about the neighbor table contents, so first of all, we have H stands for whole time handle. What it tells you? Order of the neighborship. This is telling you about order of neighborship. Then we have address, which is the IP address of the neighbor. Then interface, this is my exit interface. Then hold time. This is the hold time. This is how long the neighborship has been up. What is this SRTT? Smooth round trip time. What is this time? And get a response. Okay. How much time it takes for a packet to reach the destination and get a response. Then we have RTO, retransmission timeout. So what is this retransmission timeout? Then how long you are going to wait? How long EIGRP is going to wait if it doesn't receive an acknowledgement? So it will wait for 100 milliseconds, or you can say 100 seconds. Queue count, number of packets in the queue, or that means number of packets EIGRP is waiting to send. If it is zero, it's good. If it is more than zero, or it is non-zero value, there is a problem. Sequence number. This is the sequence number of last acknowledged packets. This is the sequence number of last acknowledged EIGRP packet. Okay. Okay. So before going over with all these things, so we have to go with. So let's talk about EIGRP neighborship criteria. EIGRP neighborship criteria. That if you want to form a neighborship using EIGRP, what are the conditions that you must fulfill? So first thing, and a very common one, what is it? AS number should be same. So number one is ASN must match on both the routers or on the neighbors. So on the neighbors, your AS number that you configure should like the AS number that you configure should match. If two routers are there, both should be in the same ASN because EIGRP is a IGP protocol. Two different ASNs will not communicate. That is the first one. Number two, A value must match. And another question I already gave you that whatever the neighborship should be there, so primary subnet should be same. Primary subnet should be same. Okay. So you can say primary subnet must match whatever the primary subnet is there. Then number three, K values must match. K values must match. In EIGRP, if you have configured authentication, in that case, authentication must match. Then passive interface should not be needed. Passive interface should not be needed. This is clear. These are the 5 neighborship criteria. This is clear. And from here, we can answer the second question. That is, EIGRP neighborship cannot be formed on the secondary subnet. For a successful EIGRP neighborship, the primary subnet must be reached. This is the condition. Okay. Let me open it. Fundamentals. Calculating best route neighborship. Okay. So you can see EIGRP is going to establish neighbor relationship or neighborship with the other routers to share a common subnet. They will exchange the topology data with those neighbors, and then they will calculate the best IP route. That means neighbor table, topology table, and routing table. Okay. But here it's explained in very short. Matrix building for not the book. Okay. So now see here, if we talk about the hello and hold interval, this thing we can see from here. EIGRP hello and hold interval. In EIGRP, we don't have the dead time. See, EIGRP has these two timers. Hello interval. So this is the interval at which a router sends EIGRP hello messages on a interface. And what is the hold interval? This is the timer used to determine when a neighbor router has failed, based on a router not receiving any EIGRP messages, including hello in this timer period. Okay. Let me go with the CCI book. Let's see what is there. IDP routing, EIGRP. Okay, this is directly going through D. Okay, so these are the parameters that must match: authentication, key value, CS number, primary address, and they should be in a single subnet. So if they differ in any, they will not become the neighbors.
Sir, the fifth point, if passive interface should not enabled means.
I'll tell you about passive interface first. What I'm trying to show you here is okay. So see here, if we talk about the hello interval, right? So it says that okay, it is 60 seconds for the slower links, and for all other faster links, it is 5 seconds. Okay. Same way, hold time is also, so the hold time in EIGRP is 3 times the hello interval. That means for faster links 15, and for slower links 180 seconds. This is the point that we have to count. Okay. I think in this book it's mentioned or not mentioned. Here also, but it's not mentioned in a bit of technical language. So let's go with the simple one. What you can say about EIGRP? So we can say EIGRP sends hello packets periodically. Okay, after a fixed interval. And the default EIGRP hello time is 5 seconds for faster links, and then it is 60 seconds for slower links. Okay. Then in EIGRP, we do have a hold interval also. EIGRP also has a hold interval or hold time, which, so what is the hold time? That means how long a router is going to wait before declaring a neighbor as inactive. It defines that how long a router will wait before declaring a neighbor as inactive. Okay. The default hold time for faster links is 15 seconds, and for slower links, it is 180 seconds. Okay. Like serial or whatever used in frame relay networks and all. That means links with a lower bandwidth. Okay. So you can say like the default EIGRP hold time is 3 times the hello interval. This is here. Okay. Now, how this is the default value? Can we change it? Yes, we can change it. Just now we saw the comments here, like this side. I can use the command IP hello interval EIGRP 100 is the ASN, and then I can give a time between the seconds. So I can give a time between 1 to 65,535. Okay. And hold time, also I can change IP hold time and then ASN number, and then I can give the seconds. Clear? So these both the comments you can use. We can change the hello time by using the command this is the command, and you can say interface name, and this is what, this is your ASM. And this one here you can give the time in seconds, and this time in seconds is from 1 to 65,535. Okay. Here. Okay. Same way we can also do what? We can also change the hold time. So one thing you have to understand here, when you change the hello time, automatically your hold time will not change. It's not like it will automatically become 3 times. No. Okay. So you can say here, changing the hello time will not automatically change the hold time. If you change the hello interval, it will not automatically change the hold interval. Is that clear? You have to manually change it. You have to manually change. Otherwise, if you will understand that, okay, I will change the hello interval and hold time will change automatically. So let's say on a faster link, by default hello time is 5 seconds. That means you will think, okay, it is consuming so much bandwidth. Let me do one thing. I'll set hello time to 30 seconds. So hello time is 30 seconds and hold time will be 15 seconds only. So one hello is sent. After 30 seconds, next hello will be sent. And neighbor is waiting only for 15 seconds. That will be problematic. There will be inconsistencies in your network. So better ways, you have to manually set it. Okay. So we can change the hold time by using the command interface name, then you say IP hold time EIGRP ASN and then time in seconds. Here and here also the time value is same. Okay. Whatever the value you have here, the same value. This is clear. If you want to check the hello and the whole interval of an interface, to check the hello and whole time of an interface, we can use the following command. What is the command? You say show IP, EIGRP, ASN, then you will say interfaces detail. So in a particular ASN, what is the hello and hold time? That is something we can check. Okay. All right. This is clear. Now, first thing we will do is we will verify these neighborship criteria. First thing we will do is we will verify the neighborship criteria, and then we will check the hello and hold interval also. This is clear. Okay. Now, first neighborship criteria is what? The ASN must match. So we'll take example of the previous topology here. Let's design a new one. The topology I'll be using R1 and R2 connected to each other. They are using the network 12.0/24. Here the IP address is 192.168.12.1. The interface is gig 0/0. Okay. Here the IP address is 12.2. Interface is gig 0/0. Yes. R1, R2. Then after this side, let's say I'll use one loopback 1.1.1.1. On this side, I'll use a loopback 2.2.2. Okay. And as of now, we are considering that they belong to the EIGRP ASN 1. Yes, 1. This is clear. No. Now let's go for the lab. So here, this subnet that you see, right? This is my primary subnet. Okay. This is my primary subnet. This is my primary IP address. Clear? If I want, I can use to verify the secondary subnet also. I can use a secondary subnet here. I can use something like, so I can use a secondary subnet, something like 172.16.12.0/24. And I can say this guy here, it is using 12.1 IP. And this guy here, he is using 12.2 IP. So this is my second bit. Clear? Okay. Okay, this is my primary subnet. Also, I'll use a secondary subnet. On 172.16.12.0/. And this is 12.1. Here I'll use 12.2. Wipe all nodes. And then start all nodes. R2 is not started. Okay. So let's do the configuration. The ASN number here we are using. This is one ASN. We will configure this log with this. complete configuration, including EIGRP. Okay. Rest of the people will check whether the configuration is right or wrong. At least mention R1 or R2. I can know which is R1 configuration, which is R2 configuration. It's okay, you can. Configuration is okay. Something is missing. Even the route. Complete lab configuration. मैंने तो बोला भी नहीं देखो. What happened? Directly connected is not being. I don't know. Run the route for data. Thank you. Not required. Not required. If you know how to calculate, you don't need to remember anything. 4 times 255 minus your subnet mask. That is your answer. Now, no need to remember for any class or anything. Then all the configuration is okay. Configuration is correct or incorrect? Yes, sir. Configuration is correct. This is just what I prefer. Okay. There is no problem with the configuration. Okay. So now what I'm going to do, the first thing we will check. Okay, so right now I'll not be giving this secondary subnet because one by one we will test. This is clear? Okay. Copy the configuration. Access R1. R2. PR2 configuration. This is done. First of all, let's check the hello and hold interval. Do show IP EIGRP 1 interface. So we can see that this is the loopback interface. On the loopback interface, my hello interval is 5 seconds, hold is 15 seconds, and on this interface also split horizon is enabled. And this is about Z0 by 0 interface. Again, I can see the hello and hold interval. Okay, let's. So you can see even on the Z0 by 0, hello and hold interval is 5 and 15, split horizon is enabled. This is clear how to verify. Now, right now they are neighbors. Do show IP, EIGRP neighbors. I can see R1 is neighbor with R2. Yes or no? Okay. Now, the first point we will try. What was the first point? ASN must match. So what if the ASN doesn't match? Like if I say here, no router EIGRP 1, and if I say router EIGRP 2, network, and 192.168.12.0. So this is the PA termination receipt. Okay. That is not mandatory. Debug IP EIGRP. And even, or simply also debug IP EIGRP. Notifications or neighbor. Mhm. So do you see if they are becoming neighbor? Debug IP EIGRP. Okay, so I gave it, but still they are not becoming neighbors. They are not becoming neighbors. So if ASN is not same, they will not even communicate with each other. Okay. And if I check here, one more thing we can do. Debug IP packet detail. So we might be receiving EIGRP hello packets every 5 seconds. Okay. So you can see there is some packet coming on 22400. So these are the packets which are going from the source 12.1 to the destination 2240010, and there are some packets coming from there. But nobody is understanding those packets. Why? ASN is different. So if ASN is different, they will not understand it. Clear? Okay. Okay. So let's say this time the ASN is same. Okay. If I say router EIGRP1, network 192.168.12.0. You see, immediately neighborship came up. Understood? Now let's say this time what I want to do is I don't want to try with the same subnet. That means I don't want to try with the primary subnet. I want to try with the secondary subnet. Okay. So if I try, do show run pipe section EIGRP. So I'll say router EIGRP1 and I'll give a no statement for this one. Done. And I'll give a network statement for 12.3. This is clear. And this side, I'll say no. And I'll say network 172.16. 12.3. Sorry. No 12.1. But instead, we are giving 12.0. Now, still what is happening? Now, I said on secondary subnet, there should be no neighborship. What I said on secondary subnet, there should be no neighborship. So if you see my neighbor is becoming with what IP address? Primary IP address only. They are not becoming neighbors with the secondary IP address. Now, why they are becoming neighbors with the primary IP address? Hello packets are going using the source address of primary. That's why. Using secondary EIGRP cannot communicate. That's why it is using again primary one. Is that clear? Okay. So second point is also clear. Otherwise, I would see a neighbor as 172.16.12.1, not 192.168. I would see a neighbor as 172.16. This is clear? Okay. Like if I go and remove that address primary, interface gig 0/0 running interface G0/0. So you can see I have a primary address. If I remove this address from here, interface gig 0/0, no. You see? If you want to delete the primary address, first you have to delete what? Secondary address. So that means using secondary, we are not able to have EIGRP neighborship. This thing is clear. What is the third point? K values must match. What must match? K values. Okay. So how do I know what K values are being used? Hmm? Do show. Okay. Show EIGRP protocol. This is the one. So I can see metric weights. So what is being used here? K1, K2, K3, K4, and K5. And out of them, which one is being used? K1 and K3 is being used. Others are 0. That means not being used. Same thing we can check here. You can show the protocol also. So EIGRP protocols. So here also I can see K1 and K3 as 1. So K values are same. Now we will change these K values. How do we change? Router EIGRP1. Now what? What will be the command? Command is metric weights. Type of service will always be 0. Then you will give the value of K1 Let's say K11, K21, K3, K4, K5. Everything given. Now I'm using all the matrices. And do you see I get a log here? What is the log I'm getting? I'm getting K value mismatch, and due to that, my neighborship is down. Okay. So you can say when we are changing, whenever you want to include the matrices in the calculation, if the K value is mismatch, the EIGRP neighborship will be down. And we will get the following log. And what will be the log message? This will be the log message, which is going to say K value mismatch. Clear? This is the log message. Understood? Now, what if they are not on the primary subnet? So far we checked, right? But we didn't check with the common, like uncommon primary subnet. What if I change the primary subnet? Then they will not become a neighbor, right? So let's see. Now let's go back and say no. Now I take back to default. So we should have the neighborship again. We have the neighborship again. Okay. Now interface gig 0/0, the primary IP I will change. IP address, let's say something like 11.112.255.255.255.0. Done. Router EIGRP1, no network, 192.168.12.0. No network. 172.16.12.0. So you see what do I get here directly? I get the error as, or what the log messages that they are not on the common segment. Okay. So note it down. If the primary subnet does not match EIGRP neighborship, and we'll get the following log. This is the second log message for K value is mismatch. Now, what if, let's say K values are same, primary subnet is same. Okay, so if I say network 192.168.12.0 and interface gig 0/0, router EIGRP1, no network, Okay, now they should be on the same subnet. Yes. Then what was the one thing was there about authentication, but authentication we will discuss in some time. Last point was passive interface should not be enabled. Now, what is passive interface? Hmm? Correct. If passive interface is enabled, then EIGRP will stop sending and receiving hello messages. It will stop sending the hello messages through that interface. Okay. So right now you can see R1 and R2 are neighbors. Those show IP EIGRP neighbors. So they are neighbors. Why they are neighbors and through which interface they are neighbors? Now, if I go and use the command passive interface, gig 012, see what will happen. I have a log. This side also. Okay. So this side peer termination receipt, and this side I have a log that the interface is passive. On this interface, I cannot form a neighborship. And you will see your neighborship is down. Clear? So this is the log message. So you can see if passive interface is enabled, EIGRP neighborship will be down and we will get the following log message. Okay. And the log message will be this one. That the interface is passive. Clear? Mhm. Yes, on the LAN side. Generally, on the LAN side, you configure the passive interface because on the LAN side, you don't have any other router with which you want to form the neighborship. In that case, you will use passive interface. This is clear? Okay. So, one note here.
Sir, what is passive interface?
I'm just telling you. If an interface is configured as passive, EIGRP will break, like EIGRP will stop sending hello messages through that interface and will break all existing neighbor relationship. This is what a passive interface is. Okay. Passive interface is generally configured on the LAN side, where we don't expect EIGRP neighbors. This is clear.
Sir, what is the use of passive interface?
Just said right that you just don't want to send the traffic on a landscape because you're not expecting any EIGRP neighborship there. Then why to send EIGRP hello messages? You just
Okay, that purpose to
correct
be enabled.
the bandwidth. That's it. With the help of passive interface, we are just saving the bandwidth. And also, it can be a security measure. How? That means if somebody connected a router in my organization unauthorized. So if passive interface is not enabled, my router might form a neighborship. My router might form a neighborship. So I don't want any unwanted neighborship in my organization with my router. Hmm? ACL, yes, that is different from passive interface. ACL, you define source IP, destination IP. Here directly we are telling that, okay, don't form any neighborship on that interface. Same. Okay. This is clear. And then about the neighbor table. So here the first thing is handle. This is what? Order of neighborship. Okay. Then we have address. So what is the address? IP address of neighbor. This is the IP address of neighbor. Then we have interface. So this is the exit interface. Then after we have hold time. This is the hold time. Then after we have uptime. How long the neighborship is up. Okay. Then SRTT. Mode down to time. Okay, this is the amount of time or how long it takes to send a EIGRP packet to a neighbor and get a response. The amount of time it takes to send a packet to a neighbor and get a response or acknowledgement. Then we have RTO, which is retransmission timeout. The amount of time the router waits before retransmitting up unacknowledged. Yeah, how long the router will wait. Then we have queue count. What is the queue count? Number of packets in the queue or number of packets area is waiting to send. Okay. This should be 0. If it is non-zero, that indicates some issue. Okay. Then sequence number. And this is the sequence number of last acknowledged. So these are all the contents of your neighborhood. Noted? Timer, full timer. Yeah, the packets. See here. So these are the 7 different types of packets. EIGRP uses 7 different packet types when communicating with its neighboring routers. Number 1, hello, acknowledgement, update, query, and reply. Okay. Then we have 2 reliable packets, SI query and SI reply. So although these packets are also reliable, the packet update, query, reply, SI query, and SI reply, these packets are also called reliable packets. Why? Because EIGRP makes sure that they are delivered and they are delivered in proper order. Yeah. So now one by one, we'll discuss about the packets also. So 7 packet types you can note down. In EIGRP, we have 7 packet types. Okay. They are hello, acknowledgement, update, query, reply, SI query, and SI reply. Okay. And out of these 7 packets, 5 packets are reliable packets. Update, query, reply, SI query, and SI reply. All these are reliable. Hmm? Who says? Who says? EIGRP itself is a completely separate protocol. Protocol number for EIGRP 88, not a TCP or UDP based. Notice. Okay. Now, take a look. So you can use this command show IP EIGRP traffic. This will tell you about how many hello query, okay, hello update query reply acknowledgement, how many packets are sent. So, sent and received. This is sent, this is received. Command is show IP EIGRP traffic. Okay, so this will show you about all of them. SI query, SI reply, and all that. Now, first of all, hello packets. So we know that your EIGRP sends periodic hello packets once it has been enabled on a router for a particular interface. And these hello messages, why the hello message is used? Hello messages are used to identify neighbors and whether these neighbors are compatibly configured. That means, are they having a common IP subnet? Are they using the same AS number, same key values, authentication? Is that clear? So first thing is it is used to identify. Second, it is used to check the compatibility. Okay. So what it checks? It checks whether they are on the same common IP subnet, authentication is there, all these parameters are same or not. Understood? Then this also serves as a keep alive. This also serves as a keep alive. Keep alive means informing the neighbor that yes, I'm alive. So EIGRP hello packets are sent to the link local multicast group. So it uses the multicast address 224.0.0.10 in the IPv4 and in the IPv6 FF02:E. Okay. In EIGRP, we can also configure static neighbors. We can also configure static neighbors. So if you have configured static neighbors, in that case, your hello packets will be unicast. In that case, your hello packets will also be unicast. The default hello interval is 5 seconds on the MDMA interface with the bandwidth setting of 1544 kbps and less. And the default hello interval is what? 5 seconds. Now, if you have a non-broadcast interface, okay, with the bandwidth setting of 1544 kbps and less, in that case, the default hello interval is 60 seconds. So that means, in simple words, for higher speed links, 5 seconds, for slower links, 60 seconds. Okay, and the EIGRP hello packets, they have an opcode of 5. Okay, and they are not acknowledged. This thing is clear. So you can note down only few things that first of all, EIGRP will send periodic hello messages. That is the first point. Second point, it is used to identify the neighbors. Third point, it is serving as a keep alive. Point number 4, they are sent on the address 224.0.0.10 in IPv4 and F2FF02:A in the IPv6. And your hello messages, they are unicast if the neighbor is statically configured. Thereafter, on slow interfaces or slower links, the hello interval is 5 seconds, and on the on faster links it is 5 seconds, and on slower links it is 60 seconds. And the hello packets, they have an opcode of 5 and they are not acknowledged. Only these points you can remember. This is clear? Like in the app also we have opcode to identify the type of packet. Okay. So opcode 5 is what? Your hello message. This is clear? Okay. So this is the hello message. Then the second message is about the acknowledgement. So acknowledgement, what it does? It is used to acknowledge the selected received EIGRP packet. Why? To facilitate reliable delivery. Okay. Then These acknowledgement keys are sent in response to your update query reply and your SI query and SI reply, and these are always unicasted. So acknowledgement package is always unicast. Okay. So with respect to the format of the packet, that means if you take a look at the contents of the packet, your EIGRP acknowledgement is basically a hello packet only, but with empty body. Empty body. That means it will not carry any routing kind of information, network kind of information. Okay. All right. So it only carries the EIGRP packet header as shown in the figure 8.3. So let's see some figure 8.3. We have here. So this is the acknowledgement number it will carry. It will not carry or any of this information. Okay. Just a moment. Check this. What is TLV? The full form, I don't recall. Okay, here it is. Type length value. TLV is type length value. Okay, so it is telling that it is used to carry the route entries. Okay, and also provide the dual information. So it will not carry any route entries. And so the acknowledgement packet uses the same opcode as hello packet. Like I said, because this is same like hello packet, it does not carry any route informations. Okay. Then after anything else is important. Okay. That is more than enough for acknowledgement. Because this is just sent to acknowledge the TCP packets like update, query, reply, SI query, and SI reply. Nothing extra is required here. This is the acknowledgement packet. Then after we will have the update packet. Now, if we talk about update packet, why the update packets are used? These are used to share the routing information. So the EIGRP update packet contain the EIGRP update packets contain routing information updates, and they are used to convey the reachability of the destination. And these update packets, they can be both unicasted and multicast. Okay. So that is more than enough. Okay, about the update packet. Because otherwise, if you will go that in what case it is unicast and what case multicast, then that will be too much of depth. You have to go with the VPN kind of concepts. Okay. Otherwise, like you see, during a new adjacency buildup, update packets are unicasted. When you build a new neighborship, in that case, they will be unicasted between the newly discovered neighbors. In some specific cases, when multiple new neighbors are detected, like in cases of DMVPN kind of scenario where multiple nodes will be there. So if multiple new neighborships are there, in that case, it will be what? Multicasted. So detected on the single multi-access interface in a short time span, EIGRP might choose to synchronize them using a multicast. So in short, if you want to say that if a neighbor is point to point, in that case, unicast. Otherwise, in DMVPN kind of scenarios or in multi-access network, it can be multi. Okay, don't say it will be, say it can be multicast. On a multi-access network, it can be multicast. This is clear. So this thing you can add in the update packets. Other than this, you can add hmm? Which part? This is more than sufficient. So if you are forming a neighborship one-to-one, in that case, it will be unicast. And if you have a multi-access network, multiple adjacencies in a small time, in that case, the EIGRP can do a multicast. Example scenario, DMVPN. This is clear. Then after, query packet. So why the query packet will be used? Hmm? When a successor and feasible successor is down, the EIGRP will do what? The EIGRP will query. The EIGRP will query the neighbors. That okay, do you guys know how to reach this particular network? So how it will query? Using the query packet only. Okay. So you can say the EIGRP query packets are used to involve neighbors in the task of searching for the best route towards a destination. Okay. And the queries are also delivered reliably. Even your query can be both unicast and multicast by default on multi-access network. Okay. With only dynamic interface, queries are sent as multicast. Okay. And if not acknowledged in proper time by the neighbor, a query is transmitted to the unresponsive neighbor as unicast. Is that clear? So in a multi-access network, what will happen? First of all, first priority is what? Multicast. But if a particular neighbor is not responding, then to that particular neighbor, it will ask us unicast. What happens on a point-to-point? On point-to-point interface towards statically configured neighbors, queries are always unicast. Okay. So if it's a point-to-point interface and if you have statically configured a neighbor, in those cases unicast. In multi-access network, multicast. Okay. So on multi-access network, I will say queries are sent as multicast. Then point-to-point interface and statically configured neighbors, the queries are always okay. And these queries can be both unicasted and multicasted. So what we will say, here I will add something. In the query packet, we will add a condition that if a route is down, So route is down means successor or visible successor. This is clear. Then, so if a route is down, in that case, EIGRP query packets are used to involve the neighbors in the task of searching for the best route towards the destination. Okay. So your queries can be both multicasted and unicasted. And by default, on the multi-access interfaces, queries are all multicast. And if it is a point-to-point interface and statically configured neighbor, the queries will be unicast. Okay. Yeah. Then reply. So reply packets, these are sent in response to the query packets to carry the sender's current distance to the destination after taking into account the topology change that prompted the query. Okay. So first of all, these are sent in response to query packet and they carry what? Carry the sender's distance to destination. Okay. The reply packets are always unicasted to the originator. Okay, one more thing in the EIGRP query packets we have to say about the opcode. Here it is 3 and in this it is 4. So then reply packets. So like I said, sent in response to the query packet, they carry the sender's current distance to the destination. Always unicasted and opcode is SI query and SI reply. We will do it practically, then only we will see. Okay, like this you will not understand. For this we require configurations. So the packet types is clear. Okay. Then next task for you is about the EIGRP topology table. Neighbor table is done. Now it's about topology. So this is what you will study for today. Study about EIGRP topology table, feasible successor, feasibility condition, variance. Okay. What is FD? What is AD? All these things. So that means anything about the topology table. That is your task. So note down the task for today. EIGRP topology table. This is your task for today. One is topology table. And for calculating variance, we also have to discuss about EIGRP method. We will talk about EIGRP method problem. Yeah, these two things are your task for today. So tomorrow we'll discuss these and complete the topology table. Okay. Online people, any doubts so far? No, sir. So this is it for the day, guys. I'll see you guys tomorrow then.